we're going to break down one of the most important ideas in all of software development, object-oriented programming, or OOP for short. So let's get right into it. Why is this whole idea so important? I mean, have you ever stopped to wonder why pretty much every modern programming language, from Python and Java to C#, is built around this concept of objects? Well, the answer is actually simpler than you might think, and it's a huge deal. See, OOP was created to fix this massive, tangled, and frankly infuriating problem that early programmers called spaghetti code. And to really get why the solution is so brilliant, you first have to feel the pain of the problem. So let's take a quick trip back in time to the world of programming before objects ruled the land. Before OOP came along, the main style was something called procedural programming. The idea was pretty straightforward. You had all your data, your variables, living in one place, and then you had a completely separate bunch of functions that would reach in and operate on that data. And this visual, man, it says it all, doesn't it? On the left, in that procedural world, you can see how the data and functions are totally separate. For a tiny program, maybe that's fine, but as your code gets bigger, you end up with this crazy tangled web where everything depends on everything else. You change one function over here, and suddenly, bam, 3 other functions over there just broke. That is spaghetti code. Now just look to the right. That's the object-oriented way. Everything is bundled up, neat, tidy, and organized. And that neat, bundled approach is exactly the solution we're talking about. So let's dive in to how this whole world of objects actually works. Okay, so this is the absolute core idea of OOP. Instead of keeping your data and functions in separate houses, you bring them all together under one roof. We combine related variables and the functions that use them into a single, self-contained unit called an object. And just to make it official, we give them special names. The variables inside an object are called properties, and the functions are called methods. The best way to wrap your head around this is to forget about code for just a second and think about something from the real world. Let's take a car, for example. If we were modeling a car in our code, the car object would have properties. That's its data, like its make, model, and color. And it would have methods, the things it can do, like starting, stopping, or moving. See how that works? All the data and all the actions that have to do with the car are bundled together in that one car object. It just makes sense. Okay, I can hear you thinking, that's great, but we're not actually coding Toyota Camrys. And you're right. So let's look at a real programming example that you've probably used 100 times without even realizing it. Think about the local storage object in your web browser. It's a perfect example of OOP in the wild. It has properties like length, which tells you how many items are stored inside, and it has methods like set item to add data and remove item to take it away. Properties and methods all tucked away inside one neat little object. Now, this idea of bundling stuff together is a great start, but to really unlock the full power of OOP, we need to understand its 4 foundational pillars. And here they are: encapsulation, abstraction, inheritance, and polymorphism. Now, I know, these sound like words from a philosophy class, but I promise you, the ideas behind them are actually really intuitive and incredibly powerful. So let's break them down one by one. First up is encapsulation. And guess what? We've already been talking about it. It's just the official, fancy name for bundling related data and methods into a single object. This is the bedrock principle that keeps our code from turning back into that dreaded spaghetti. And this slide shows you the huge practical benefit. On the left, in the old procedural world, to calculate a wage, you'd have to pass in 3 separate pieces of data into a function. But on the right, with OOP, the employee object already contains its own salary, overtime, and rate. You just have to tell it, get wage. No parameters needed. It's so much cleaner. This perfectly illustrates a famous saying in programming by Robert Martin, also known as Uncle Bob. The best functions are those with no parameters. The fewer things you have to pass into a function, the easier it is to use and understand. Encapsulation is the key to making that happen. All right, let's move on to our second pillar. And to understand this one, let's use another real-world analogy. Think of an old-school DVD player. Inside that DVD player, there's a ton of complex stuff going on. Lasers, spinning motors, logic boards. But on the outside, all you see are a few simple buttons: play, pause, stop. You don't need to know how the laser reads the disc. All that complexity is hidden from you. That is abstraction. We hide the messy internal details and only show the simple, essential parts. This gives us two huge benefits. First, a simpler interface just makes our objects easier to work with. But second, and this is so important, it reduces the impact of change. Think about it. If the engineers invent a better laser for the DVD player, they can swap out the internal parts, but your play button still works exactly the same. That internal change doesn't break anything on the outside. Our third pillar is inheritance, and this one is all about being efficient and smart. It's a powerful way to eliminate redundant code by creating new objects that are based on existing ones. Check out this example using HTML elements. A text box, a checkbox, and a drop-down list all share some common features, right? They all have properties like being hidden or visible, and methods like being clickable. Instead of rewriting that same exact code for every single element, we create one generic HTML object and have the others simply inherit those shared features. This helps programmers follow a key principle known as DRY. Don't repeat yourself. And that brings us to our fourth and final pillar, polymorphism. The word literally means many forms. In programming, it's a super powerful technique that helps us get rid of those ugly, repetitive, and hard-to-read if-else or switch case statements. And this comparison just shows how powerful this is. On the left is the old procedural way. To draw different HTML elements on a page, you'd need a long, clunky switch statement that checks the type of each element and then calls the correct drawing code. Ugh. But on the right, with polymorphism, each element object, the text box, the checkbox, has its own render method. You can just tell any element to render itself, and it already knows how. A single, elegant line of code replaces that entire messy block. It's beautiful. So after all that, let's zoom out for a second and put it all together. What are the big picture benefits of using object-oriented programming? This table sums it up perfectly. Encapsulation reduces complexity. Abstraction isolates the impact of change. Inheritance eliminates redundant code. And polymorphism gets rid of those ugly conditional statements. Each pillar directly solves a common, frustrating problem in software development. Together, these four concepts give you a powerful blueprint for writing code that's more organized, more flexible, and way easier to maintain over time. So now that you understand the blueprint, the only question left is, what are you going to build with it?